All right, good afternoon. I wanted to say something about what a good crowd we have for them serving beer and food downstairs, but I was afraid to say that because you might leave. So please stay in your seats. All right, so good afternoon. I'm Colonel Jim Price. I'm a special assistant to the Director of Operations, Headquarters, Air Combat Command, where I serve as a lead for the Point Defense Task Force that we have, and we're the lead command for the Air Force. I'm responsible, and my organization is responsible for training and equipping combat-ready airmen to defend installations and assets and personnel against aerial threats, including small unmanned aerial systems, and we're delighted to welcome you to this panel today. Unmanned aerial systems are an emerging technology that has rapidly spread around the globe, creating unique security challenges. UAS are often small, mass-produced, difficult to track, and have already delivered outside effects in combat around the globe. Ukraine's Operation Spiderweb highlighted the strategic implications of disregarding UAS, specifically small UAS. As a threat, they successfully destroyed multiple strategic aircraft deep inside of Russia. The propagation of this cheap and often untraceable technology requires generational evolution and how nations operate to address this threat. Everyone, from policymakers to warfighters, are weighing in on the impact being made by this evolving technology. To confront this threat, we must work across the services and government agencies to identify and fill seams to defend the force. This includes fielded, deployed combat forces and those within the airbase or garrison perimeter. For this and many other reasons, the Secretary of War recently stood up the Joint Interagency Task Force to address this need and deliver joint counter-UAS capabilities to our warfighters. Without question, industry partners will be an integral part of any solution. They're engineers and technical experts developing new kinetic and non-kinetic components and the command and control background required to defend from this prolific threat. To discuss this challenge, as well as solutions, I'm joined on stage by four leading industry experts in this field. First, I'm joined by Michael Hiatt, Chief Technology Officer, Defense, Epirus. Welcome, Michael. Next, I'm joined by Kons Muhtaris, Senior Principal, Program Management, L3 Harris Technologies. Welcome, Kons. Third, Jon Piatt, Executive Vice President, ISR, Aviation and Security, Sierra Nevada Corporation. Thanks, John. And last, but certainly not least, Jon Theuerkauf, Vice President, Engineering, Frequentis Defense. Thanks, John. Appreciate you being here. All right. Without further delay, let's get into some questions. So this is for all of you, and we'll just start, right here. Talking about the threat environment. From battlefields across Ukraine to the Middle East, UAS fundamentally alters the way we need to think about air defense. Can each of you briefly share your thoughts on the challenge posed by UAS? Go ahead.
Sure, thank you, Colonel. UAS proposes a unique challenge in that it stresses every part of the kill chain. It also doesn't supplant any of the existing missions that we had in terms of air defense. You still got to worry about cruise missiles, hypersonics, manned aircraft, all those types of things. And so because of that, a lot of the existing systems aren't quite as effective or are overkill in terms of, everyone talks about cost asymmetry. And so as we look towards solutions that can deal with that, we need to consider all those things, whether it's cost or magazine depth. Those tend to be really driving a lot of the narrative in a lot of the, what we see, whether it's the Red Sea and the Houthis launching cheap cruise missiles there, or whether it's what we saw, Operation Spiderweb, as the Colonel mentioned, or Operation Rising Lion, where the Israelis went in and disabled all of Iran's air defense and basically ran unencumbered. And so we got to learn all those lessons. I know it can sometimes be a challenge to learn a lesson from someone else's expense, but it's a cheap way to do it, and we should take advantage of that. Thank you.
Yeah, so we at L3 Harris really look at the counter-UAS as a wicked problem, and it really is a complex problem that's out there. I think that all of you are aware of. The speed of the threat evolves much faster than industry or even or government can catch up with. So we have to be quick in how we evolve. drones are now starting to operate on different frequencies. It's no longer the old 2458. If you look at Ukraine today, they're flying everywhere from 300 all the way up to 6 gigs plus. You have to be able to scan that frequency if they're flying on RF. If they're flying on something like fiber, you have to be able to respond to that. If they're flying using complete waypoints or AI/ML to figure out what the terrain is, you have to be able to understand what's that drone's weakness or ability to address it. And the threat and the software evolves so quickly, as does the production of those drones, that it becomes really hard to catch up. And the Ukrainians have done a good job in trying to keep up, right? But it's still a persistent problem. So you've got to look at the speed of the response, the speed of how we address our changes, right? Whether it's industry or government, and how we can, from an industry perspective, get it to the government in time so that it can respond fast enough and be integrated in such a way that we can make the response fast and not a whole cycle of you tell me, I integrate or innovate, I come back to you, you test it, and then continue on. Sometimes it's going to have to be much more fluid than that and much more reactive. Thank you.
Thanks, Scott.
Yeah, I think to pick up on where that carries us forward, it's the open architecture aspect from where we have to start with our initial design concepts, because to the point, the threat is evolving rapidly, and in our combat-proven solutions environment that we're dealing with currently, we're having to see ourselves integrate new effectors in days. New effectors onto the same launcher platform, into the same ecosystem, so we can get those kinetic solutions that are better aligned to how that threat is evolving. And then the other aspect of it is open architecture allows us to plug and play emerging, not the kinetic, but the non-kinetic solutions as well, because we have to be adaptive in a layered way that allows us to better proliferate our own systems, our own offensive and defensive systems in an open architecture that doesn't, let's say, hamstring you to the OEM either. You need to be able to field systems that other people can update so we can take full advantage of industry technology, and especially when we're looking at how quickly the threat is evolving, we need to allow our industry to evolve as well without saying, I'm going to field a whole new effector, I'm going to field a whole new platform, I'm going to start all over again. This is going to help us evolve our TTPs faster. It helps us adapt and then create a pathway or avenue for other technology and industry to merge into what we've already started.
Yeah, and I think another unique challenge that we face with the unmanned aerial systems is the fact that they are so prevalent out there, used for proper missions, right, by our forces, but also by the public for doing work, for delivering packages, for everything, and that's only going to increase from here, right? So that is a significant difference that we face with drones that you're not going to face with a lot of these other weapon systems out there. So trying to tackle that by identifying them, identifying good from bad, is going to be a huge aspect of this, of tackling this challenge.
Great. Thanks a lot. That was a good way to set us up. So as a follow-up, what are the foreign policy challenges associated with confronting this threat when it comes to allied and coalition operations that you guys are tracking? Go ahead.
Boy, that's a long list. Obviously, being able to do counter UAS domestically is a big challenge. I think there's been some public, reporting on incidents at Langley, Eustis, and some other bases. And the ability to take out and engage drones, there was jurisdictional issues, there was issues with the effectors they had available not working against the drones that were there, and we need more options. We need to be able to engage, we need to be able to make sure we have the ability to do the detect, track, and ID, and be able to see where those drones came from, because a lot of times it's a law enforcement thing, CONUS, and then with OCONUS, even protecting our bases abroad, there's a lot of host nation interaction that's going to be a big challenge. And each of those host nations will have their own unique versions of the FAA with their own hurdles. So that's going to, there's definitely no shortage of policy challenges, regardless of what your chosen effector is or your chosen sensing. Even, getting a radar authorized may interfere with some local, comm system or something like that. So, no shortage of challenges on the policy side there.
Thanks, Kons.
So I look at it from the three C's perspective. You have communication, coordination, and then compliance. The policy question on the compliance side plays a big role of it, but as does the communication and the coordination. As we have our host nations and our partners out there, we need to be able to tell them what systems we have. They need to be able to tell us what systems they have, and establish some kind of communication between the two so that we understand what each one of those systems have, how we can pass information to them, and how they can pass information back to us. But more importantly, if you are going to go active, if you are going to affect, there's going to be a good amount of compliance that goes around that. You can't go hot in an urban environment. I mean, that's, unless you're in a war, right, you're not going to do that. You can't do certain electromagnetic effects, right, in certain areas because it may interfere with somebody's 5G cell phones or their other communications infrastructure. So understanding where and what you can do becomes a really hard part of it. And unless you're coordinating, communicating, it's not going to happen. So open architecture, being able to go back and forth, communicate, whether it's, you know, whatever, Sapient in the UK and NATO or something else, you've got to pass in information, then pass back, but also understand what you can and can't pass back, and then moderate a little along those lines.
Yeah, I'm not going to give you too long of an answer because I think whether it's domestic or international, policy is the Achilles heel that keeps us from actually doing something. So if we don't get to a minimum viable capability with minimum viable threshold, that policy has to be broken at some point in order for us to understand how do we take out the threat. It might even mean that policy has to be aligned with minimum viable losses in order to say this is when we trigger that. We've seen a lot of that over the last couple of years in a operational environment, and we can't allow policy to be that Achilles heel as we're going forward and we're seeing this threat evolve.
Excellent, thanks.
Yeah, the only thing I wanted to mention, I think obviously we have our status of forces agreements overseas that are telling us what we can and can't do in those areas, and I think that having high-level diplomacy and working out these challenges with our partners overseas is going to be very important.
Excellent, thanks a lot. All right, and we'll start down with you at the end, John, on this one. So we dressed the overseas a bit here, and we kind of started going into the United States policy changes. If you'd like to address anything about some of the challenges you see in the United States, that'd be great. But we also know that, Mike, you talked about how we have seen some instances in this country. What do we do? What are some of the things we need to lay out and start doing to protect ourselves here? So we'll go ahead and start with you.
Sure. I mean, obviously in the U.S., we have to work very closely with the FAA to manage traffic. I think hand in hand, having some unmanned traffic management capability is going to be very important because otherwise we're going to be not knowing if the drones that are flying around are actually nefarious, rogue, maybe someone just doesn't know what they're doing, or is someone up to no good. And I think having that capability and that working together with the FAA is going to be very important. And obviously right now we can't do a whole lot outside of the base perimeter, and that's something that obviously we need to work out with the FAA.
Yeah, notwithstanding the FAA restrictions, kind of goes back to what I said earlier. We need to have the ability to define what those keep-out zones are, because we need to be able to say, if you're operating in this area with a UAS, it's a kill zone, either kinetic or non-kinetic, and kinetic can be last resort inside of the U.S., but we've got to have the ability to stop it before something happens, especially when we start talking about critical infrastructure, national security assets, base protection, especially when we saw, as you referenced, what happened with the drones that the Ukraine used against Russia. No idea that it was coming. If we can't protect against that, we can't have the ability to say now, and even outside of the perimeter, increasing the situational awareness, taking advantage of our sense and detect so we can track an ID before it enters the perimeter. That allows us to at least get the appropriate response before something happens.
Excellent. Kons.
Yeah, so back to the wicked hard problem. I look at it and I think we have our 130I exceptions, right, of what you are and you're not allowed to do, but I feel sometimes that they can be construed in a way that doesn't allow you to want to do what you may want to do. And you may only get one shot to do that. And is this the one time that you want to hit that button, as we were speaking about a little bit outside? So how do you do it, right? I think policy definitely has to take a look at it. How some of the regulations are written and some of the education, I think, can be looked at. The other part of it, too, is how do you, and this is one of the things that I'd be really interested in seeing actually evolve, is how do you progressively and how do you structurally implement something like almost like a DMV database for your good flyers, right? We're going to have remote ID, right? The FAA is going to be able to track everything. So for the folks that are flying, I'll call it legitimately, right? And may not be intending to do something, at least you know who they are, you can kind of set them aside. But have the authority for the ne'er-do-wells, right? If somebody is flying something that they have control of and you can actually intercept and find out what that system is and obtain its MAC address or unique ID, create your DMV database, right, that all law enforcement, whether it's federal, tribe, state, local, can all address, just like we do with the regular, all our police, right, and our federal institutions, and be able to identify what that threat is. So if I see a drone that is flying today at Langley Eustis, and then I see it flying over SwiftPack, and then I see it flying one of our Air Force bases, I probably have a problem that I need to go address and figure out what that pattern looks like and give it over to law enforcement to go implement. So policy's got to help drive that, and policy has to work in creating these infrastructures to allow us to exchange that data very efficiently.
Great, thank you. Michael.
Yeah, two things to add there. I think that potentially leveraging the 124N authority, which is more for domestic law enforcement, DHS partnerships and things like that, especially for CONUS applications, that might give a lot more flexibility to base commanders. That's obviously a complicated issue there. But one thing that helps it be less complicated is having a set of effectors that can be low collateral. Obviously, if you take a drone out, even perfectly, it falls. But at least, do things that avoid putting metal in the air in CONUS applications. I think everyone is going to be a fan of that. Jamming also has its own challenges in terms of denying, local, other users that are authorized on that spectrum. And as we mentioned in the outset, there's a lot of drones operating at all sorts of random frequencies. So having something that has the ability to operate CONUS with low collateral, I think that creates a big opportunity to solve some of those policy challenges, because you're no longer asking to hey, I want to set up CWIS to be shooting off. That's not clearly a no-go, and that's where high power microwave. I'll plug my thing there. Gives a lot of good options there in terms of being able to take out drones with low collateral effects.
Thanks. All right, so something that this crowd's particularly interested in is these things are relatively cheap. And we always come up with a high-tech solution that's going to cost a lot of money to bring them down. So when we talk about cost per effect, instead of shooting multi-million-dollar missiles at these things, which are relatively inexpensive, how does cost per effect work, and how are you guys looking at that for making this cheaper for us to defend our country? We can't have that ratio all the time, right? So let's go ahead and start at the end with Jon, and if you guys will give us a quick answer on that.
Yeah, sure. So, for Frequentis, we don't really manufacture effectors or the sensors, but we bring everything together. I think when we're looking at putting solutions together, it's finding the most cost-effective way of mitigating the drone. But we're not actually in that manufacturing business, so it's more of a same analysis that you would do.
Okay, thanks.
So we tend to think about cost per effect or cost per munition based on the system we have. What I'd like to look at, and what we are doing currently, is we're taking munitions we wouldn't be using otherwise, and we're repurposing air-to-air munitions into ground-to-air munitions, especially when we start looking at the changing dynamics of the war. We're not going to be using a lot of the aircraft in these contested environments. So by repurposing those munitions, it changes the whole aspect, at least from that perspective, on a cost per munition, because it really is the effectivity of kill to prevent the cost or life cost of avoidance. So you're actually making better use of something that otherwise may not come out of the warehouse. And we've got several effectors that we've integrated onto our platform, that into a single-use platform. Then at the same time, then thinking about the forward look when we have to continue to build up more munitions. And again, we don't build the munitions either, but we love using other people's munitions because they focus on what they do best. We focus as a mission systems integrator with an open architecture platform that says, okay, give me a 2.75 guided rocket that's $22,000 a piece, and I can put 46 of them onto my launcher, and if I need to go kinetic, I've got plenty of magazine depth, I've got plenty of range, and I've got plenty of kill capability up to a Class 3 drone. That is one way we can get to it as well, because as we start to use up our munitions, now we're going to have to replace them, and that's when it's going to be an even greater cost equation. Then the other piece of it is again, being able to adapt the non-kinetic solution. So when you have that option to go non-kinetic, now we can start to think about cost per kill differently. And then there's also high energy lasers, which we're integrating into our systems now. That is going to, again, as I said earlier, open architecture allows us to take the same system, evolve the system itself, allow us to put in multiple effectors, and then you start to do a matched effector to the kill ratio or the kill solution.
Okay.
Yeah, so completely agree. And that's very much the approach that we take a look at. Try to see what's already in the MTOs, right? Try to understand what's already in your arsenal. Reuse that. So as we look at our Vampire solution within L3 Harris, we really look at what we can take that's existing. APKWS for us has been a great success out in the Ukraine. And it's a proven system. Air to air, air to ground, ground to ground. It's worked, or maybe not air to air, but so much as air to ground and ground to ground. It's been a fantastic weapon that is low cost, but utilize it because we have a lot of it in inventory. When you start going with your group 1 and 2s, maybe you need to move to a 7.62, maybe you need to move to a 50 cal, maybe you need to move to a directed energy or high power microwave. So the way we're building our software and our architecture is in that open framework where we can quickly, very quickly, I'm talking weeks, right? Not necessarily months and months of integration efforts to be able to implement that and get it back to the warfighter very quickly. But it's not just a cost per kill, it's also got to look at the whole cost of the system. You can't have a low cost per kill system that costs you $55 million or $100 million. It's got to be scalable. It's got to address it from the sensors all the way to the effector on what and how much each particular mission set can afford to put out there and can then go sustain. We sometimes forget about the sustainment piece on the back end, but it's a really important part to consider.
Yeah, I think the one thing to add is oftentimes, cost gets a lot of a lot of the headlines. Everyone talks about, how much did the United States and Israeli combined response to take out all those Shaheds cost? But the cost of running out of ammo and the cost of having, magazine depth issues, the pilots aren't making that decision of like, oh, got to hold back on the AMRAAM. Maybe I'll use, something else. They're thinking more of like, what do I need that AMRAAM for, and how do I conserve that from a magazine depth perspective? Now, and that's where, again, things with much deeper magazines, directed energy, or, some of the really low cost kinetics, those can be the thing that is able to sustain. Because when we look at, whether it's, the things that have been deployed out in CENTCOM, the bad guys can count. They know how many rockets are in a box, and they will figure out how to deplete that magazine and then send in more stuff. And so that's where having that both layered defense and the ability to have things with significantly deeper magazines like directed energy are really going to play a role there. Thank you.
All right, awesome. You kind of teed up the next question a little bit, and we'll, some of you have already addressed this a little bit, so if you don't need to reiterate, that'd be great, and we'll get it to another question. But basically what we're seeing in Ukraine is that, we've relied on electronic warfare up to this point. We want to do it that way. It's a lot easier, right? And as far as having projectiles out there and around people we don't want to hit. But we also see that the enemy or people are using fiber or other things to make that very difficult for us. If you string a fiber cable behind one, or et cetera. So if you could comment on that, where do we go for this non-kinetic, or how does this work in the future? I appreciate that. So let's go ahead and start with Michael on this end real quick.
Great, thank you. I think you'll get firm alignment from everyone on this panel that layered defense is the key. And so anyone who's been around in counter-UAS for a while, there's been some snake oil over the last 10 years. And anyone who says that they've got the silver bullet is lying to you. And so that's where that layered defense is so important, because things that fiber optics are great from if you're going to try and defeat EW, because there's nothing to jam. But there's solutions that are great against it. Hyperbaric microwave, kinetics, they can all go right through and affect that. But then you start to look at well, what else are they going to do, and how do they overwhelm some of the other solutions? We got to have those layers, and to be able to integrate those layers seamlessly, because if you have too much cognitive overload, if you have too much time of like, oh, it'll take 10 minutes for me to switch over, it's like, well, you lost. And so the idea is seamless and done in a way where the operator isn't having to make a lot of decisions. We have to have some level of scalable autonomy, some level of decision aid and engagement aid to help the operator make those decisions very quickly, process a very complex work environment, threat environment, where things are coming in fast. You may not have. You've got the fog of war. You don't know. These things don't have IFF. So is it a friendly? Is it not? Maybe you can get a couple pixels on it from an EOIR, and you have to make a fire decision. You've got lieutenants, junior lieutenants making those decisions in BDOCs in CENTCOM today. And so how do we make their job easier? And I think that's a combination of layered defense with the ability to do smarter decisions. Thank you.
Right, thanks, Con.
Yeah, so again, the layered approach, right? I think we've all talked about that. When I look at the problem, and when we look at the problem at L3 Harris, I've got a little moniker. We call it simple. It's got to be smart. It's got to be intuitive, integrated, modular, proven, and then it's got to have a low cost of total ownership, not just the low cost of the device itself. So smart, right? It's got to be able to implement some kind of AI ML in order to reduce the cognitive burden off the warfighter. To your point, right? When there's the fog of war and everything going on around you, you want to have significantly less noise or din being provided to you in terms of data and information that you have to parse through. So if there are algorithms that can help you do that, or machine learning that can help you do that, that's what we want to implement. That's what we are implementing. It's got to be intuitive. You cannot make it hard for a warfighter to go ahead and engage a weapon or understand what a sensor is telling them. And you've got to help them understand what weapon system they've got to be able to use in certain scenarios. So you may not be firing a rocket. You may be firing something else or using electronic warfare. There's different capabilities. So we try to simplify it that way. It's got to be modular. If you want radar, great. If you don't want radar because artillery is going to hit you, you don't have to have radar, but you have to have that interconnectivity so that you can get the information so you know where your effector needs to point to. If you're passive, right, and you need to be passive only and you're in a conceal mode, be able to pass the information back to whatever data center, TOC, or base is processing the information. And then, again, proven, right? You've got the good technology, you know it'll work, and it's affordable across the board.
Thank you.
Yeah, in the interest of time, I'll keep this short. Michael said something I want to foot stomp. There's no silver bullet. And the second piece of it is, I'm not thinking about how we train the warfighter. I'm thinking about how we train the civilian, because when it comes down to it, and when we see what's already happening elsewhere in the world, we have to train people who are not warfighters to be able to use a system in a way that helps protect our infrastructure and our assets. So that's the simplicity of how we have to train our capability and be able to train fast. We're talking days. We can't go through months-long training. It has to be a system that's simple, that's agile, as you mentioned, and it translates beyond the warfighter and into the civilian workforce, because those are the ones that are going to be helping us with base protection and infrastructure protection more than the warfighter, because the warfighter is going to be needed elsewhere for more important things on the front lines. So just point that out.
Great, thanks.
Nothing else to add. I think
Right.
yeah,
Thank you
covered
very
it.
much. All right, so scalable solutions. So we've already talked about how this is spread throughout the world. And Ukraine recently announced they were going to produce, I think it was 4 million small drones in a year, this coming year. How do we keep up? how do we expand our, our industry, or what do we do to keep up? So, John, we can start with you down here.
Sure. When Frequentis thinks about scaling our solutions, it's more about understanding all of the different traffic that's out there, as I mentioned before. With the FAA Part 108 regulations coming into account next year, I think we're going to see even more unmanned traffic flying beyond visual line of sight in the U.S., and that's going to be something that's going to be very important to manage both between the FAA and the Department of War to ensure that we have that situational awareness, right? So seeing the overall air situation display with the unmanned traffic that is proper and doing proper operations versus rogue traffic or nefarious traffic is going to be very important. And that's why we focus on having a situational awareness that brings in all the different type of radar feeds from the civil side, as well as anything on base to give the base commanders that oversight, but also across different bases. I think it's going to be important to be able to track if things are occurring to try to coordinate a response across them.
Expanded network integration that allows us to take advantage of distributed architecture or multinodal sensing. We use our track software for integrating our own systems as well as other companies' systems. So you get the ease of integration, so you're sharing data, low latency, real time, because it is one thing just to share data. It's another thing to get the data where it needs to be in order to be able to make a command decision. So it's network integration. It's being able to proliferate sensors that are not all doing the same thing, because we need to, when we talk about scalability, it's not just about the volume capacity of the production or what we can do to put more effectors. It's what we can do to create a distributed defense network that allows us to optimize that network. And then the scalability says, how do we control network from centralized command and control, so then we can start putting in the AI and the automation of the kill chain so we can do a better job of matching up the effector to the threat. So scalability is more than production. It's more than just the number of sensors you put out there. It's how you do the systems integration of that sensing capability so you can improve your probability of kill and you can then optimize the kill chain over time.
Great, thank you.
Yeah, I'll foot stomp that. That really is a direction we need to be heading into. Going back to that simple concept, right? Integrated. It's got to be integrated. It's got to be able to take, say, one of our Westcam sensors, right? If I've got video of something that's sitting on one of his birds, be able to transmit that location from an ISR perspective back to wherever it's relevant so that they can go and make the right decision. And as things evolve and more automation is being put into place, now you can start taking all the rest of the sensor data and start making some really smart decisions on it. So yeah, 100% agree.
Yeah, let me be real clear. We can't keep up with China and drones. I'm sorry about Replicator. It's not going to be able to do it. We just are not set up. We've spent 40 years offshoring manufacturing. They are better at producing cheap electronics than we are. We need a different solution. We can't do one versus one. We have to get into one versus many. We have to have effectors that can be effective against a significant number of drones. So we need EW, but then they harden EW. We need to be able to do more. That's where you need the directed energy. You need things like high power microwave that can take out a volume of drones. A couple weeks ago, we took out 49 drones in less than a second. The only reason that it was only 49 is that's how many we bought to put up. It's a lot of work to put up swarms of drones, if anyone has done it before. But we can take them out. And that's what you need. We need to think differently, because one versus one is what we've been doing since the beginning of SHORAD, since the beginning of air defense. And that's how we've always done it. And the drone threat is too different. We cannot scale and match it one-to-one. So that's my plea for thinking differently, trying to think of how do we take out many, many drones very effectively. Thank you.
Great, thanks. All right, we're coming to a close, and we about have enough time for everybody to give a 1-minute closing statement. Anything that you weren't able to talk about you think is important for this audience? And we'll go ahead and start at the end with you, John.
Not really. Nothing else to add.
Great.
Thanks.
Thank you, John. Thanks for...
I think if you want to see what all we've talked about come down to our booth downstairs. You're going to see our launcher. You're going to see our multi-effector launcher assembly. You're going to see our track software integration. You're going to see the experience that we've already got in a combat-proven environment that says this is how we adapt, this is how we evolve, and to the point that the rest of the panel mates made up here, the open architecture system that says I can add stuff in days, not weeks or months. I can add the non-kinetics as the non-kinetic technology evolves and plug and play into an existing architecture, and then minimize the amount of the workforce that we need. So come down to our booth, see what we're doing. We'd love to show you more and love to share more information.
Thanks.
Yeah, echo some of that. We're also helping and we're also evolving. Right around beginning of October, we're going to be announcing a little bit about what we're doing for the next step of Vampire, the next generation of Vampire, as we're evolving the system to fit and try to take care of a lot of the problem sets that we're seeing here, right? Again, bringing it back to simple. And if you want to learn more, please come down to our booth. I'll be here for the rest of the evening. We'll have some other folks there. If you also plan on attending AUSA, I know it's an Army show. But we're also happy to chat with you there or even beforehand. Again, thank you all.
I don't mean the last thing between you and happy hour, but yeah, we have a booth as well. Love to chat. This is my favorite thing to talk about in the world. And I do want to say, don't let perfection be the enemy of good enough. We got to get things out now. We have vulnerable warfighters out there. We got to make sure that they get protected. Thank you.
Great. No, that was a great closing comment. We appreciate that. Hey, thank you all for being here. It's a wicked problem. It keeps a lot of people busy. It's going to take a team. It's going to take a lot of people to get this done. And we thank you for helping us to start that conversation here and have a good rest of your day. Thank you very much.